How did some of the smallest military vehicles ever built end up outperforming machines many times their size on the world's most unforgiving battlefields? In mid-1970s, in Sweden, the landscape was frozen forests, roads barely 8 feet wide, and snow deep enough to swallow a truck. Heavy armor couldn't move, yet one compact machine floated right over it. Stay with this and subscribe, because the engineering behind that breakthrough quietly reshaped strategy across 3 continents. Sweden's northern forests, mapped in the early 1970s by the Army's terrain analysis teams, revealed a truth. The average secondary road measured just 2.5 meters wide, barely the length of a compact car. In winter, those tracks vanished under snowdrifts deeper than 30 centimeters, sometimes over a meter in February, according to Riksarkivet survey memos. For the Swedish Army, whose Cold War doctrine still relied on heavy tanks and armored vehicles, these numbers weren't just inconvenient, they were disqualifying. Standard tracked armor, including the Sturvey 121, simply couldn't pass. Not only did their width exceed the roadways, but their weight meant they would sink or break through snow and soft ground, especially when bridges in the north could barely support a few tons. The Defense Materiel Administration's FMU 71 report, filed after months of fieldwork, documented these constraints in detail. Engineers noted that even the best-maintained forest roads narrowed unpredictably, sometimes pinching to just under 2 meters. Snow cover, measured in repeated February surveys, routinely exceeded what any conventional military vehicle could traverse without getting stuck. The data pointed to a contradiction at the heart of Swedish defense planning. The vehicles designed to defend the country were too large to reach many of its most vulnerable regions. This wasn't just a Swedish problem. Across Scandinavia and in other remote theaters, the assumption that bigger meant better was running into a wall of geography. The procurement brief that followed demanded something radical: a carrier that could float over deep snow, squeeze through sub-2-meter corridors, and still haul a full infantry squad. The numbers from the terrain survey didn't just challenge old doctrine, they forced the military to rethink what a combat vehicle could be. The next step would test whether such a compact solution was even possible. Stay with us and subscribe, because the answer would upend more than just Swedish strategy. Field trials for the Bandvagn 206 did not just meet expectations, they rewrote the rules of what a military vehicle could do in the far north. On the test ranges outside Arvika, the prototype's ground pressure registered at 0.11 kilograms per square centimeter. That number, buried in FMVTR technical reports, meant the BV-206 could float over snowpacks that swallowed every armored vehicle before it. During the winter of 1975, engineers recorded continuous travel through 80 centimeters of fresh snow, terrain that had previously forced entire battalions to halt or divert. The BV-206's articulated chassis and wide tracks distributed its weight so evenly that, according to Hägglunds' after-action sheets, the vehicle left barely a trace on the surface. The breakthrough was not just technical, it was institutional. In July 1976, the Defense Materiel Administration issued a procurement order for 210 units, the largest single buy of a cold weather carrier in Swedish history to that point. The contract, documented in FMV's V7612 file, cited cost per kilometer savings and operational data from the Norland exercises. Lieutenant Colonel Goran Lindstrom, who led the test team, later recalled, "It was the first time we had a machine that could go where the maps ended and the snow began." This measurable success was not a lucky accident or a stopgap. The BV-206 proved that a purpose-built, compact vehicle could outperform larger, heavier platforms, not despite its size, but because of it. The ground pressure figure became a benchmark, and the procurement order signaled a new era, one where small, specialized machines would define mobility doctrine for decades to come. Torque is the silent muscle behind every small military vehicle that outpaces its weight class. Inside the Bandvane 206, a 1:20 final drive ratio transforms modest engine output into the kind of force needed to crawl up icy slopes or drag a loaded trailer through slush. This means for every turn of the engine, the tracks rotate just once for every 20 revolutions at the crank, delivering controlled, almost stubborn pulling power at low speed. On a gear stand, this principle is plain. Spin the input fast, and the output moves slow but with far more strength. For the BV-206, this gearing was not just about brute force. It let the vehicle keep moving where resistance, snow, mud, or even water would stop conventional trucks cold. Amphibious travel posed a different challenge. Water drags at a hull far more than snow or sand. In lab tests, engineers measured a 30% reduction in drag after reshaping the BV-206 lower hull and sealing the articulation joint. This was not an afterthought. Field reports from 1975 document the prototype crossing flooded marshes at a steady 3 kilometers per hour with the tracks acting as paddles. The sealed hull kept water out, while a simple bilge pump managed any seepage. These details, gear ratios, hull shapes, and drag coefficients sound abstract, but in the field, they were the difference between a stranded column and a squad that could reach the far bank. Understanding how torque is multiplied and how drag is minimized arms us with two principles. Small vehicles win not by overpowering obstacles, but by working with the physics of their environment. These are the tools that will reappear as the investigation moves from Arctic forests to jungle rivers and desert sands. In the jungles of Vietnam, the rules of mobility changed again. The M274 Mule, weighing just 1,100 pounds, became a lifeline for infantry cut off from roads and facing terrain that swallowed up even the smallest trucks. On paper, the Mule looked almost comically simple. A flat platform, 4 wheels, and a modest engine. But its size was its secret. It could slip down footpaths 1.5 meters wide, disappear beneath the tree canopy, and cross ground that left jeeps and larger vehicles stranded. What mattered most was not how much the Mule could carry, but where it could go and how quickly it could get there. Medevac reports from the 1st Battalion, 327th Infantry, dated May 1968, record 36 casualty evacuations performed by mules in a single month. The difference was not just in numbers, but in minutes. The Mule could reach wounded soldiers in places where helicopters could not land and stretchers could not pass. Field Manual 5510 describes a 2-rope sling procedure for the UH-1 Huey, specifying a lift speed of 120 feet per minute with a mule as cargo. This meant a team could load the vehicle, attach the sling, and have it airborne in less than 3 minutes, far faster than any alternative. Corporal James Miller, a mule driver in the 1st Battalion, 327th, remembered a night run along a flooded jungle trail. He said they could hear mortars in the trees, but the mule kept moving. If you could fit your boots on the path, you could bet the mule would fit too. His account, preserved in the Veterans History Project, captures the reality behind the stats, a machine built not for show, but for survival. The mule's low ground pressure and compact form made it the only option for emergency resupply and evacuation in the thickest parts of the Central Highlands. In Vietnam, size was not a limitation. It was the only way out. Long before cold forests and jungle trails, the Western Desert forced a new kind of thinking. The Long-Range Desert Group, operating deep in the Sahara, faced terrain that swallowed heavy trucks in minutes. Their solution was as simple as it was effective. Drop tire pressure to just 12 pounds per square inch, about 80% of the normal setting. According to Imperial War Museum diaries, this single adjustment cut ground pressure almost in half, letting stripped-down Chevrolet 300-weight trucks glide across sand where others bogged down. The patrol log from January 15, 1942 records every detail. 3 trucks, tires deflated, crossing the Wadi Zarana in under 5 hours, reaching the Italian outpost before sunrise. Not a single vehicle was lost, only one puncture. The diary credits the early arrival and the complete surprise of the raid to the decision to run low tire pressure. In the desert, size wasn't about armor or firepower. It was about knowing when less weight and less pressure turned sand into a highway and surprise into a weapon. Military doctrine favors the predictable, heavy armor, thick steel, and engines built for brute force. But the official tables told a different story. NATO's maintenance directive for vehicles with less than 25 kilopascals of ground pressure, as codified in FM 3035 and STENAG 436034, required weekly lubrication of every articulated joint and track roller, a cycle that consumed 2 hours per vehicle every 7 days, regardless of miles traveled. Procurement memos from the early 1980s reveal persistent resistance. Officers warned that doubling the light carrier fleet would overwhelm field workshops, not with breakdowns, but with routine service. Yet the trade-off was clear. These compact vehicles, with their low ground pressure and modular drivetrains, kept mean time to repair under 4 hours, far below the 12-hour average for main battle tanks. The logistical burden shifted from catastrophic failures to relentless, scheduled upkeep. In the end, the mobility edge came at the cost of discipline, a doctrine rewritten not just by what could move, but by what could be maintained in the field. Today, militaries still measure capability by size and strength. Yet battlefield reality proves that specialized, compact vehicles can outmaneuver expectations and rewrite doctrine. In war and engineering alike, the smallest details reshape outcomes. Keep questioning what power really looks like. For more investigations, subscribe and join the search for hidden truths.